NFPA 70, the National Electrical Code, has requirements for grounding portable generators when they're used in certain situations. These situations include, firstly, when supplying power to structures, equipment, or systems that require grounding; secondly, when used in hazardous, classified locations; thirdly, when used in damp or wet locations; and fourthly, when used in conjunction with any equipment that requires grounding, such as hand tools. Even if the generator is isolated from ground, an individual using a hand tool is still protected from electrocution for several reasons. Ground fault circuit interrupter protection is one reason. Most hand tools used in demolition, such as grinders and pipe cutters, are equipped with ground fault circuit interrupters. Ground fault circuit interrupters are designed to interrupt the power supply if an imbalance is detected between the supply and return currents, indicating a fault or a potential shock hazard. Double insulation is another reason. Many hand tools also have double insulation, meaning they have two layers of insulation between the live parts and the user's body. Double insulation provides additional protection against shock hazards even if one layer of insulation fails. Low voltage supply is another reason. The portable generators used in this scenario typically supply 120 volts alternating current, which is a relatively low voltage that reduces the severity of any potential shock hazard. In addition to ground fault circuit interrupter protection and double insulation, it is also recommended to use extension cords in good condition and to avoid operating equipment in wet or damp environments. Therefore, while the portable generator may not be directly grounded, individuals using hand tools connected to it are still protected from electrocution due to ground fault circuit interrupter protection, double insulation, low voltage supply, and other safety measures. Grounding is generally considered a good safety practice and can help to minimize the risk of electrical shock. Grounding creates a low impedance path for fault current to flow back to the source, which can trip a circuit breaker or fuse and de-energize the circuit. This is why grounding is typically required for electrical systems and equipment. However, in certain situations, such as when using a portable generator to power equipment through extension cords, grounding may not be required by code. This is because the extension cords provide a degree of isolation from ground, and the equipment is typically double insulated or ground fault circuit interrupter protected. However, it is important to note that even when grounding is not required, it is still a good idea to take precautions to protect yourself from electrical shock. This includes using ground fault circuit interrupter protector extension cords, wearing appropriate personal protective equipment, and avoiding contact with wet or damp surfaces. Several factors determine whether or not a portable generator needs to be grounded. Firstly, the type of equipment being powered is a factor. If the equipment being powered requires grounding, then the generator must also be grounded. Secondly, the location where the generator is being used is a factor. If the generator is being used in a hazardous location, such as a construction site, then it must be grounded. Thirdly, the voltage of the generator is a factor. If the generator is producing more than 120 volts, then it must be grounded. There are several ways to ground a portable generator. One way is to connect the generator to a grounding rod that is driven into the earth. Another way is to connect the generator to a metal water pipe that is buried in the ground. The National Electrical Code provides guidelines for grounding portable generators. The NEC states that portable generators must be grounded if they are used to supply power to equipment that requires grounding or if they are used in a hazardous location. The NEC also provides guidelines for the size and type of grounding conductors that must be used. Ground fault circuit interrupters are designed to protect people from electrical shock by monitoring the current flowing through a circuit. If a ground fault circuit interrupter detects a difference in current between the supply and return conductors, it will trip the circuit and interrupt the flow of electricity. Ground fault circuit interrupters are typically required in areas where there is a risk of electrical shock, such as bathrooms, kitchens, and outdoor areas. Double insulation is a type of insulation that provides two layers of protection against electrical shock. Double insulated tools and appliances do not require grounding because the two layers of insulation provide adequate protection. Double insulation is typically used on portable tools and appliances that are likely to be used in wet or damp environments. It is important to regularly inspect extension cords for damage. Damaged extension cords can pose a serious electrical shock hazard. Extension cords should be replaced if they are cracked, frayed, or otherwise damaged. It is also important to avoid overloading extension cords. Overloading an extension cord can cause it to overheat and potentially start a fire. When using a portable generator, it is important to take precautions to protect yourself from carbon monoxide poisoning. Carbon monoxide is a colorless, odorless gas that can be deadly. Portable generators should only be used in well-ventilated areas. Never use a portable generator inside a home, garage, or other enclosed space. In addition to the points already covered, here are some more detailed explanations and considerations regarding electrical safety with portable generators and hand tools. Firstly, let's discuss ground fault circuit interrupters in greater detail. A ground fault circuit interrupter is a fast-acting circuit breaker designed to shut off electric power in the event of a ground fault. A ground fault occurs when there is an unintended electrical path between a source of current and ground. This can happen if someone touches a live wire or if there is a fault in the wiring of an appliance or tool. Ground fault circuit interrupters work by monitoring the current flowing in the supply and return conductors of a circuit. In a properly functioning circuit, the current flowing in the supply conductor should be equal to the current flowing in the return conductor. However, if a ground fault occurs, some of the current will flow through the unintended path to ground, creating an imbalance. The ground fault circuit interrupter detects this imbalance and quickly trips the circuit, cutting off the power. Ground fault circuit interrupters are designed to trip very quickly, typically within 20 to 30 milliseconds. This is fast enough to prevent serious injury or death from electric shock. Ground fault circuit interrupters are required in many areas of the home, such as bathrooms, kitchens, and outdoor areas, where there is a higher risk of electric shock. They are also commonly used on construction sites and in other industrial settings. Secondly, let's talk about double insulation in more depth. Double insulation is a safety design used in electrical appliances and tools to protect users from electric shock. It involves providing 2 layers of insulation between the electrical conductors and the outer casing of the device. The first layer of insulation is the basic insulation that is applied to the wires and other electrical components. This insulation is designed to prevent current from leaking out of the conductors. The second layer of insulation is provided by the outer casing of the device, which is made of a non-conductive material such as plastic or rubber. This casing is designed to prevent users from coming into contact with any live electrical parts. Double insulated appliances and tools do not require grounding because the 2 layers of insulation provide sufficient protection against electric shock. This makes them safer to use in situations where grounding may not be available or practical. Double insulation is commonly used in portable power tools such as drills, saws, and grinders, as well as in many household appliances. Thirdly, understanding low voltage supply is important. The term low voltage can be relative, but in the context of portable generators and hand tools, it typically refers to 120 volts alternating current, which is the standard voltage for household electricity in many countries. While 120 volts alternating current can still be dangerous and cause electric shock, it is generally considered less hazardous than higher voltages. The severity of an electric shock depends on several factors, including the voltage, the amount of current flowing through the body, the path of the current, and the duration of the shock. Lower voltages generally result in less current flow, which reduces the risk of serious injury or death. However, even at 120 volts alternating current, it is still possible to experience a painful and potentially dangerous electric shock. That's why it is essential to take precautions when working with electricity, even at low voltages. Fourthly, let's consider safe practices for extension cords. Extension cords are a common source of electrical hazards, so it is important to use them safely. Here are some tips for using extension cords safely. Firstly, inspect extension cords for damage before each use. Look for cracks, fraying, or exposed wires. If you find any damage, do not use the cord. Secondly, use the correct size extension cord for the job. The size of an extension cord is determined by its gauge, which is a measure of the wire's thickness. For high power tools and appliances, use a heavy-duty extension cord with a low gauge number. Thirdly, avoid overloading extension cords. Overloading an extension cord can cause it to overheat and potentially start a fire. Check the power rating of the cord and the appliances or tools you are using to make sure that the total power draw does not exceed the cord's capacity. Fourthly, do not run extension cords through doorways or under carpets. This can damage the cord and create a trip hazard. Fifthly, keep extension cords away from water and moisture. Water can conduct electricity and create a shock hazard. Sixthly, unplug extension cords when they are not in use. This will prevent them from being accidentally damaged or overloaded. Consider other safety measures as well. Firstly, always wear appropriate personal protective equipment when working with power tools and electricity. This includes safety glasses, gloves, and footwear. Secondly, be aware of your surroundings and avoid working in wet or damp conditions. Thirdly, never bypass or disable safety devices, such as ground fault circuit interrupters and double insulation. Fourthly, if you are not comfortable working with electricity, hire a qualified electrician to do the job. In summary, while portable generators may not always require direct grounding, there are multiple layers of protection that help to prevent electrocution when using hand tools. These include ground fault circuit interrupters, double insulation, low voltage supply, and safe work practices. By understanding these safety measures and following them diligently, you can significantly reduce the risk of electrical shock when working with portable generators and hand tools. It's important to remember that electrical safety is an ongoing responsibility. Always be vigilant and take the necessary precautions to protect yourself and others from harm. Consulting with a qualified electrician or safety professional can provide additional guidance and ensure that you are following all applicable codes and regulations.